Hello, welcome to Internet of Things class. And this module we'll be looking at Internet of Things, hardware, sensor, and embedded system. And in doing this, we will look at sensors and the actuators. We also look at the types of sensor and how it is being applied. Look at the embedded system in Internet of Things, the microcontroller and processing units. We'll look at the power management in Internet of Things devices, and lastly, we'll look at wireless electricity transmission concepts as it pertains to Internet of Things. Now, the effectiveness of any Internet of Things system is largely dependent or determined by the capability of its hardware components, which serves as the interface between the physical and the digital world. And the module actually focuses on the foundational hardware elements that enables Internet of Things devices to be able to sense, process, and also respond to real-world conditions. And these components forms the physical backbone of Internet of Things systems. And these are also essential for understanding how data is being captured, is being interpreted, and how it is being acted upon within connected environments. And this module also provides a critical technical foundation that prepares you as a learner to engage with more advanced Internet of Things networking, data processing, and also the application of topics in subsequent modules. Looking at sensor and actuators, when we talk about sensors, it's actually, and actuators, they are core hardware components that enables Internet of Things system to be able to interact effectively with the real or physical world. And this together forms the foundational or functional bridge between the real world environment and the digital system, allowing the Internet of Things devices to be able to observe conditions, make decisions, and also perform actions. And sensors have the capability of detecting, measuring, and responding to physical, chemical or biological change in the environment, and by this it will be able to convert real world phenomena into electrical signals or digital data. And on the other hand, the actuators performs the complementary role, whereby it complements the sensors by enabling the Internet of Things system to be able to act upon the physical environment, executing physical actions based on commands received from control system or embedded processors. And this sensor actuators interaction forms a closed loop control system that is foundational or fundamental to Internet of Things functionality. There are types of sensors, and these different types of sensors are designed for specific measurements and application, and this depends on the environment and the system requirements. And the first we'll be looking at is the temperature sensors. And when we talk about the temperature sensor, it measures heat or cold. That's the temperature measuring of heat or cold, and it is used in climate control, industrial monitoring, and healthcare. And as per the another is the pressure sensor, which detects force from liquid or gases, and it's applied to in the automotive, the industrial, and weather system. We also have the humidity sensor, and this measures the moisture level, and it is essential when we talk about the agriculture, HVAC, and food storage. There is also the motion sensors, and this performs the work of detection of movement, and it is used as per security, smart lighting, and traffic monitoring. We have the proximity sensors, which detect object presence without contact, and it's applied in automation and robotics. We have the light sensors also, which measures light intensity, and it is used in smart lighting and agriculture. There is also the gas and chemical sensors, which detect specific gases or chemicals. And this is actually critical for safety and environmental monitoring. Here is the sound sensors, and it's able to detect acoustic signals, and it is used in noise pollution monitoring and voice activated devices. We also have the vibration sensors, which measures mechanical oscillation, and it is essential for predictive maintenance in an industry. And lastly, we have the biosensors, and for this, it's able to detect biological signals, and it's being used in the healthcare, wearables, and medical diagnosis. Going into the embedded system in Internet of Things, an embedded system is actually a combination of computer hardwares and softwares designed for a specific function within the larger system. And unlike the general computer, embedded system is actually or are dedicated to one particular job, enabling devices to be able to function autonomously without human intervention. So there is no need for anyone to intervene because it has a singular job to perform. And we have the key component of Internet of Things embedded system. The first is the processing unit, and this deals with usually a microcontroller or the digital signal processor. And we also have another component, the memory, and this is a small amount of RAM and flash memory for code and data. There's also the input output interface, and talking about the ports for connecting sensors and actuators. And we have the power management module, and this is the circuitry to minimize energy consumption. And we have core characteristics of it. We have the real-time performance. In terms of real-time performance, we have it actually consumes low power, and also it's high in reliability and stability. And lastly, it's a compact form factor. It's in compact form factor. As per the role of localized computing, which when we talk about it, it's about edge intelligence. And one of the most significant trends in Internet of Things is a shift towards edge computing, and it's made possible by embedded system. And by definition or by explanation, edge computing refers to processing data locally on the device rather than sending all data to the cloud. It's being processed locally on the device instead of having to send it to the cloud. And we have key benefits of edge computing. The first one is as per the bandwidth conservation, which is only important alerts or processed data are sent to the cloud. Also, it has a benefit as per enhancement of privacy, where sensitive information can be analyzed locally without leaving the device. Also, it reduces latency in terms of decisions are made on site for instant responses. And lastly, it improves reliability, where system continues functioning even with intermittent connectivity. An example of this is smart smoke detector, the wearable fitness tracker, and we also have the industrial monitoring system, which all leverage on edge computing for faster and more effective operation. As per the microcontrollers and processing units, and at the heart of the embedded system lies the microcontroller and the processing unit, and they provide the computational power and control capability required for Internet of Things operation. And the microcontroller is a compact integrated circuit that combines a central processing unit, memory, input or output interface, and peripherals on a single chip. And key functions include the conversion of raw sensor into input into meaningful information. It also have a function of triggering physical response based on processed data. It also function in handling wireless protocols like Wi-Fi, Bluetooth, and LoRa. And it also perform edge computing tasks in terms of performing local computation to reduce latency and bandwidth usage. For power management in Internet of Things devices, it is actually a critical aspect of Internet of Things device design, and this is because most Internet of Things device operates in a resource constrained environment, and they often rely on batteries or energy harvesting sources, and efficient power management helps to be able to ensure longer device lifespan, consistency as per operation, and also a reduced maintenance cost. And in doing this, we have five different approach for power management. And the first one is low power hardware design, that is selecting energy efficiency components. Another approach is the energy efficient communication protocol. Um, also have the duty cycling and sleep modes, and this deals with alternating between active and sleep states. You also have the energy harvesting technique, which deals with using solar, thermal, and or kinetic energy. And lastly, on the approach is the adaptive power management, and this deals with intelligent algorithm that adjust power usage dynamically. Looking at the last aspect, which is the wireless electricity transmission concept, this is also known as the wireless power transfer, and it is an emerging technology with significant implication for Internet of Things system. And this actually enables the transfer of electrical energy within physical connectors or wires, offering a solution to the energy limitation of battery powered Internet of Things devices. And we have methods of wireless power transfer. The first is the inductive coupling. The second is the resonance inductive coupling. You have the radio frequency energy harvesting, and we have the laser or microwave transmission. And the advantage of this to Internet of Things, it's the reduction of battery dependency, also enabling continuous operation of remote devices, and supports device miniaturization, and lastly, it facilitates large-scale Internet of Things network. In conclusion, the module has been able to deal with or talk about hardware and energy foundations of Internet of Things, and it has focused on how devices interact with the physical world through three core pillars. The first is sensing and actions, the second is embedded intelligence, and the last one is the energy sustainability. And as per the energy sustainability, it deals with the prioritizing of efficient power management and exploring of emerging technologies like wireless electricity to sustain device in resource constrained environment. Thank you for listening.